Question 5.3 for 2 marks. It wants me to complete table 3. So table 3, we know, well, we need to fill in this and this. So we know this is ln 1 over t. So shift ln 1.85 times by 10 to the power minus 2 will give you minus 3.99. So all it's going to be is shift ln 3.70 times by 10 to the power minus 2 minus 3.30, and this one, well, it's going to be 1 over t, so it's going to be 1 divided by 302, which will give me 3.31 times by 10 to the power minus 3. 5.4. Our English equation can be written as this. In this experiment, rate constant k is directly proportional to 1 over t. Therefore, ln 1 over t is equal to minus ea over r 1 over t plus c2. Use values from table 3 to plot a graph of 1 over t, y-axis against 1 over t on the grid. 1 over t, you know what, let's do this. So we know 1 over t is the x-axis, ln 1 over t is the y-axis. Well, ln 1 over t therefore is going to be, it's going to be this, right? And we know, we've already got 1 over t plotted. We know ln 1 over t, 1 over small t, yep, is this. So we know when the temperature, or when, actually let's plot this. So we know that we have got minus 4 to minus 2. So we can say this is 0, minus 1, minus 2, minus 3, minus 4. We know when 1 over capital T is 3.5 times by 10 to the power minus 3. ln 1 over t is minus 3.99. Is minus 3.99, which is like here. We know that when 1 over t is 3.39 times by 10 to the power minus 3, we get a minus 3.30. So 3.39 times by 10 to the power minus 3. It goes up in such a long, this is such a weird, just plotting graphs, I don't like it. So we get minus 3.30. So what is it? Shift ln 1 over 27. Yeah, minus 3.30 at what time? 1 over t. Well, it's going to be 3.39 times by 10 to the power minus 3, and we know it goes up in, that's 5, that's 10, that's 15, that's 20. 3.40 minus 3.30 is 0.1. 0.1 divided by 20. If it goes up in 0.00 5 times by 10 to the power minus 3. So if we do 3.00 minus 5 times by 10 to the power minus 3, we get 3.395. What do we want? We want 3.39. So This is 3.395, this can be 3.39 at minus 3.30. So really terrible plotting of the graph. But you get the point. It's going to be a straight line. Because straight line, y equals mx plus c. So we know that y equals mx plus c. Therefore, we know mx plus c. This m, the gradient, is equal to minus ea over r. So if we find the gradient, how do you find the gradient? We do y2 minus y1 over x2 minus x1. Let's choose, I don't know, these 2 points here and here. So what, minus 4 minus 2 over 3.50 times by 10 to the power minus 3 minus what is that point there? 3.50. No. 3.31. Yeah, it must be that. Minus 3.31 times by 10 to the power minus 3. And we get a gradient is equal to minus 6.64 times by 10 to the power 3 Kelvin. And we know m is equal to minus ea over r. We're trying to find the activation in GEA. So therefore minus ea equals equals minus 6.64 times by 10 to the power 3 times by r, which is 8.31. We get minus EA as and therefore we divide by minus 1, and we also divide by 1000 because we want in kilojoules per mole to the power minus 1, and we get 55.2. kilojoules per mole to the power minus 1. That is the end of question 5.3 and 5.4. 5.3 very easy, just complete the table. 5.4, the hard part in my opinion is the plotting the table. Obviously the reason, I apologise for how terrible this graph is plotted, but I need to practice on it clearly, but it also is harder to do it on using a mouse. But then once you plot the graph, you know it's y equals mx plus c, compare it to this, you know, okay, so the gradient is minus EA over r. So if we want to find out the activation energy, we find the gradient using this equation, y2 minus y1 over x2 minus x1. Find out the gradient. Obviously in this case, if we use these values, we won't get the gradient that we want. We get m is equal to minus 6.64 times by 10 to the power 3 Kelvin. And then we know m is equal to minus EA over r, minus EA is equal to m times by r, m, minus 6.64 times by 10 to the power 3 times by r, which is equal to 8.31. And then divide by minus 1, we'll get the activation energy, but that will give us in joules per mole to the power minus 1, we're in kilojoules per mole to the power minus 1, so then we divide it by 1000 and we get 55.2. So hard part again, for me is plotting the graph, but once you've got it, you can quite easily find the activation energy by comparing them. Just remember, straight line graph y equals mx plus c, compare them and you can find the gradient. End of question 5.